Hello, this is Irv Shapiro with MakeWithTech. And in front of me here, this very impressive set of boxes is an Ender 5 S1. Now, this is a printer I've been waiting for a long time. The second printer I owned over 3 years ago was an original Ender 5. And over the years, it was truly one of my favorite 3D printers. I like the box design. It just seems to make sense to me that it would be more stable and produce higher quality prints at higher speeds. And in fact, I found the original Ender 5 was maybe 20 or 30%, maybe even 50% in some circumstances, faster than a traditional Ender 3 because I could crank up the speed, and because of the rigid box design, there'd be less vibration. But I wasn't satisfied with my original Ender 5, so I upgraded it. I upgraded it a lot. By the time I donated it to a local school about 6 months ago, it had a 32-bit control board, it had auto bed leveling, it had a new all-metal hot end, it had a direct extruder, I had reinforced the cantilevered bed just a bit. All things I thought would improve the printer. Well, Creality has now released a printer that's my Ender 5 with all of the upgrades I envisioned and more. Specifically, this Ender 5 is claimed to be very fast. So folks, stay tuned and let's learn something together. If you're new to this channel, you may not know that MakeWithTech is a whole community. It consists of a user forum at forum.makewithtech.com where thousands of people exchange ideas about making stuff, a lot of 3D printing stuff, and you can even share photos and files with each other. It includes models.makewithtech.com, a unique repository of 3D models where you don't just select a model. Think of it as the Canva of 3D printing. If you're familiar with Canva, the graphical design program, you select a template and then you modify it the way you want, and then you download your model, making it very unique. And of course, it includes this YouTube channel. So if you enjoy what I'm doing, if you want to support me in doing more, please subscribe to the channel. If you like the video, click on like, but most importantly, share this channel with everyone you know. Now, let's look at some of the basic highlights of this Ender 5 S1. So it's 250 by 250 by 280. That's a pretty typical print size, actually slightly smaller than the Ender 3 S1. The highlight from Creality is it's fast at up to 250 millimeters per second. Now, I've seen those claims from Creality in the past. They weren't always true about some other printers. We'll see if it's true about this one. To do it, it takes the same Sprite extruder, which is a really good extruder that's used in the S1 series on the Ender 3, and it adds a different configuration with a much larger heat block. It's physically larger. I'll show you pictures of this. And that allows it to heat up the filament more rapidly so it can be extruded more rapidly. Other highlights include auto bed leveling built in. It has the ability to add acrylic panels around the outside to make it an enclosed printer. I really like this design. I'll talk about that a little more later on. It has of course, a 32-bit control board running a variation of Marlin 2, a touch panel with a new configuration of the software that's very, very easy to use, and it sells at least in January, beginning of January 2022, which might be the time of sales, but it sells for $579. So that's $100 more than the current selling price on the Creality site at $479 for the Ender 3 S1 Pro. So is this box frame worth it? Well, it may be if you're looking for a lot of speed, because the S1 Pro, one of my favorite 3D printers nowadays, is not any faster really than the standard Ender 3. Now, on the other hand, it comes with 3 basically sections of parts. This is not going to be a 5-minute assembly. And so in today's world, where a lot of printers consist of bolting on the gantry onto the base and you're basically done, I have some concerns about the difficulty of assembling this. Now, I'm not going to do the assembly on camera because I don't think it's a good use of your time anymore, since Creality produces just really excellent videos on their site for assembling their printers. So I'm going to go off and assemble this printer. I'm going to do some initial prints, and then I'm going to come back and tell you what I learned. Now, something you need to know is that I did not pay for this Ender 5 S1. The folks at Pergear, an Amazon distributor of technology products and 3D printers that I've worked with before, provided me this Ender 5 S1 at no cost. Now, in today's world, I get 2 to 3 requests a week from manufacturers that want to provide me with products for reviews. I decline the vast majority of them. So there's plenty of product for me to review. I can get plenty of product at no cost. So there's no incentive for me to necessarily give a good review just because I got the printer for free. Well, it's already been a very long morning, so I hope you don't mind if I drink a bit of coffee while we discuss this very interesting printer this morning. You see, unrelated to 3D printing, I was trying to pay a cable television and internet bill. What a frustrating experience. I've been in the software industry for over 40 years, and this website is unintelligible to me. Back to the Ender 5 S1. I feel like a bit of a Dr. Jekyll and a Mr. Hyde. On the one hand, this may be the very best 3D printer that Creality has ever manufactured. It is truly a high-end industrial grade machine, or at least a prosumer grade machine, capable of printing at very high temperatures, capable of being enclosed with a $100 enclosure kit from Creality, and capable of both excellent quality while printing quite fast. On the other hand, because of engineering requirements, as a direct result of the need to, or the desire by Creality to make a printer that prints very fast, the setup of your slicer is a bit more complicated. And you see, I'm a Mac user. The version of the slicer that came on the SD card is for a Windows machine only. So I thought I'd just download the standard version, current version of Creality. I use it all the time. No profile for this, so I took a standard Ender 5 profile and I made some modifications, and my initial prints were very stringy. Yet the sample prints off the SD card, we'll talk about these in a minute, were perfect. So it took me a while to get things under control. I'll show you exactly what I did towards the end of this video, so make sure you watch to see that segment. Now let's take a step back and talk about assembly. The assembly of this printer is not difficult at all, but it's long. And the reason is, first you take these extrusions, you bolt them on the base. Well, the first thing you'll notice is there are no sort of slots for them. So you just sort of have to line them up over the screw holes, and then the screws go in from underneath. So you have to use a trick I've used on a lot of 3D printers. Pull the printer off the edge of the table so you can get to the screw holes underneath. Not too bad, but don't tighten them all down because you're going to have to put a gantry on the top, and you're going to want these to be able to wiggle around a bit to get the screw holes on the top lined up. So get it all assembled with your screws lightly finger tight. Then go to opposite corners and start tightening things down both on the top and the bottom to get it squared up. Like I said, not difficult, but it took a bit of time. Next, you have to assemble the print bed, and I'm going to move this slowly because it's attached to a stepper motor, and stepper motors are DC motors. So when you apply current to a DC motor, it turns. When you turn it manually, it generates electricity, generates current. That's going to go into the control board, and unless they have diodes on the control board ensuring that current doesn't go back into the control board, it could damage it. So always move the parts on a 3D printer very slowly if they're attached to stepper motors. Well, you have to bolt this onto the back Z gantry, and it's not hard to do. I did it upside down the first time. The stepper motor goes on the bottom. Make sure you put the stepper motor on the bottom. If you have it flipped around the other way, it's not going to fit. So then you have to bolt that in. The cable management is next. Cable management on this printer is excellent. You can only see part of the printer from this view, but there are no cables hanging all over the place. But there is one unusual feature. You can just see at the top of the screen. I'll show you a better photo of this, and that is there's something that looks like a Bowden tube in the top. This is a direct extruder printer. So what is this tube? Well, it's literally just the guide for the filament. You can pull it in and out of this end. It locks on the other end. And you need to pull it out to get the filament in initially, potentially when you're loading filament. It's also used as part of the cable management system to hold the cable on the top up and away from various parts. So follow the instructions for the cable management. You want to get all the cables tied down properly. They give you some custom clips. Overall, when you're done, you have a really robust printer that can print very fast. Now, my only problem was the table was wiggling around. So you want to put this printer on a solid table that's not going to wiggle around. I have it on this adjustable table that I really like that goes up and down, so I can use this as a standing desk or to work on in a standing position. But you really want it on a stable base. So overall, very impressive. Next, let's talk about this hot end. And I'll see if I can grab some photos off the Creality website to show you some close-ups of this. If not, I'll take some myself. It's an impressive piece of engineering. It's basically the Sprite extruder from the Ender S1 series. That's a high-quality extruder that's capable of pushing a lot of filament. And that works very well because it's a direct extruder with both flexible and non-flexible filaments. But in the case of the S1, that extruder that pulls the filament through is right on the hot end. In this case, there's an extra large heat break, a set of fins in between the extruder and the hot end. Why do you need that? Well, this printer can go to 300 degrees Celsius, and it can do that at very high speed. That means that even more so than the S1 Ender 3 S1 Pro, which is also 300 Celsius, it needs a larger heating element. So the heating element on this printer, I don't know if you can see it here, maybe you'll see it in some of these close-ups, is quite large. That also means that you need a slightly different nozzle. The nozzles that are used for this have a much larger screw area to get through that hot end so it can butt up to the throat above it. So it's quite a different setup. In addition, on the back here, I'll make sure you see a picture of this, is a unusually large fan, but it's very, very quiet. And then there's a 3D printed contraption underneath here that directs the airflow right to below the nozzle where you want to cool it off on the bed. Now it's interesting because Creality never uses 3D printed parts. So my guess is they were experimenting with the design of this part till the very last minute. Maybe in later versions of this printer, it will be injected molded. But on my print, it's a 3D printed part, probably in a material that can handle higher temperatures. So impressive hot end. But because of all that heat and the extreme cooling, it's likely you can get more stringing. So I found I had to lower the temperature below what they recommended to about 180 degrees Celsius when printing PLA. And I had to increase the retraction. I have a table of all this that I'll show you at the end in order to get decent prints. Now, another criticism you'll see on the web about this printer is there are none of those nice knobs that Creality puts on a lot of printers now to adjust all the belts. And this is the same setup as most Creality printers. It uses belts and it uses little wheels to attach to extrusions. Now, to adjust how the devices, the head and everything else, run on the extrusions, you have eccentric screws that can tighten the wheels or pull them apart. You have to make sure you check those on your printer when you first set it up. And my belts were a little loose, so I needed to tighten them, but there are no wheels here. Well, it ends up, there are screws at the back, and there's actually a lock screw that locks it down. So everywhere there's a belt, there's a way to adjust it. It's a more industrial process than just turning a knob, but this is a more industrial 3D printer. So that didn't bother me at all. You'll notice when you're printing with this printer, there are very good controls for adjusting parameters while it's printing. You'll also notice that when you're in the front menu system, there's no save parameters option that must happen automatically. Now, before we look at, I'm going to move my coffee cup out of the way so I don't spill it on myself. Before we look at a bunch of these prints, I want to talk about bed leveling because it's a bit unusual. So to level the bed, you turn on the printer. Yes, it's pretty darn quiet. In fact, this might be one of the quietest printers that I've used. Now, you go to the front panel, which is very clear. It's a new setup. I'll show you some close-ups of this. And you go down to Settings, and then Level Method. There are two level methods. One is called Aux level, and the other is called Auto. You want to start in Aux. There's a picture of a house on the screen. You want to hit that picture. And what that's going to do is run the print bed all the way down to the bottom, then measure the distance to the top and run it up to the top. Now my printer, when it came out of the box and ran it up to the top, to the home position, there were about 2 millimeters between the nozzle and the bed. And I looked at the knobs underneath, and they're really nice big knobs on this printer. To adjust the bed height, there wasn't enough screw distance left. So what I realized is that the first step in manually leveling this printer is to adjust your Z offset. That's the offset between the bottom of the CR Touch. That's the auto bed leveling sensor on this printer, which is basically a rebranded style BL Touch. And you have to adjust the Z offset so that the bed moves up so it's just below the nozzle. And you do that with a piece of paper in there, and you want to be able to hear a gritty noise when you're pulling the paper back and forth. So aux bed leveling, start by adjusting the Z offset when in the home position. Now I've already done that, so it's pretty tight, but this is on springs, so I can push down on this, insert a piece of paper here, and listen to the sound. Hear that sound when I pull it through? It's not tearing the paper, but it's rubbing pretty good. That's the sound you want to hear. Then you can go to all of the individual corners. So I'm going to hit the 2 button here. It's going to take it to this opposite corner. And then you can adjust your paper, adjust the knobs. So in every position, you hear that same sound when you're pulling your paper through. At that point, you have manually leveled the bed. So step 1, hit the home button. Step 2, adjust the Z offset so the center position is causing the paper to just catch, just be tight, then check all your corners. I would go through twice because as you adjust the corners, the other side is going to move a little bit. Next, go to Auto Level, hit Start. You can take the paper out. In fact, you have to at that point. And you can go ahead and level your printer. Now, a good technique would be to bring your bed up to temperature before you do this auto level step. So I'd bring the bed up to about 40 or 50 degrees. You don't need to go higher when you're auto leveling. So I'm going to let this go to the top position and let it begin auto bed leveling so you can see a little bit. I'll speed it up a lot, and then we'll look at the prints from this printer. Okay, now let's look at some prints. Well, the first thing I did is I printed the two models that came on the SD card. The SD card on this printer is a full-size SD card. I may have already mentioned that's the same size as the Ender 3S1 Pro, not the Ender 3S1. So the Pro in this printer may share the same control board. I didn't open it up to actually look inside. It starts with a rabbit. Very small print. I've noticed the printing manufacturers have small print samples now, so they print quickly. The print head was really moving, printing this. It was moving quite fast. This is a beautiful print. There's nothing to say bad about it. There was almost no stringing at all between the ears, where you're likely to see stringing. Next was a benchy, and the benchy was beautiful. Clear. Layer lines were not very viewable. This is in Hatchbox PLA. A beautiful print. Then I printed in some Creality red PLA. This beautiful model, which is designed for folks like me that need a place to store their glasses. It actually goes this way so they don't lose them. I love this model. Comes in male and female versions. And this is a beautiful print, but there was a lot of stringing. Now the string is very fine stringing, but there was a lot of stringing. On the other hand, the surface is just really, really nice. The numbers on the bottom, the label on the bottom is very clear. Next, I decided to print a vase. This vase comes from the models.makewithtech.com site. It's a site I produced that has a variety of model templates. Instead of models that have templates, you select a template, then you can customize it to make things exactly the way you want them. How many twists, how high, how wide, how big. Wonderful, wonderful site that I'm very proud of. And we're in the process of moving towards release candidate 1, where we're going to load over 500 templates onto the site that will allow you to configure tens of thousands of models. Very exciting. So aside from that though, this started printing very slow. Then I remembered there's a problem with Creality printers. Creality printers implement the standard Marlin power fail recovery. Here's how it works. Every time your printer changes layers, goes to a new layer height, it takes and it saves that layer height to the SD card. Now, that's fine when you're printing traditional prints. Not going to have any impact. But the layer height is continuously changing in a vase mode print. So the printer is trying to save those layer heights to the SD card. Writing to an SD card relative to other things is relatively slow. So it causes vase mode prints to print very slow. And in fact, because they're printing so slow, you get a bunch of drips and drabs around the printer. They don't look as good as they should look. So you have to disable power fail recovery. Well, guess what? On this printer, once you start a print, I couldn't find a way to do it before you start the print. But once you start a print, in the tune section, there's a disable power fail recovery option. You can just click that on. Alternatively, you can do what I did and just turn it off completely. And the reason I turn it off completely is it doesn't really work. So you're printing a big old layer. You save the layer height. You start printing a layer. You're halfway done a layer that takes 5 minutes to print, and the power goes out. When the power comes back on, your printer is going to try to start again at that layer. That's going to cause a layer shift if I've ever seen one. So yes, your print might complete, but it won't really work. The better technique is just put a UPS on your 3D printer. For 50 to 100 bucks, you can get a UPS that'll last a little while. If your power is going to be out for a really long time, power fail recovery is probably not going to work anyways, because your printer is going to the temperature is going to fall. When they bring the nozzle temperature back up, it won't stick to the filament that's already there. So I think a UPS is a better approach. So how do you permanently turn off power fail recovery? Well, in the G-code start code, you add a command. The command, which you can see here on the screen, is M413S0. So you go into your slicer, you go into Manage Printer, you go to the G-code start code, and you add that to the G-code start code. And that's what I did. So once that was done, this printed quite quickly, and it's a beautiful print. I like printing vase mode prints that don't have uniform surfaces because the variations in the surfaces seem to make them stronger. This is just a very nice print. Next, I wanted something really complex. I wanted to see if I could do a flexible item with moving parts, but I wanted to see if I could do it really fast. So I cranked the slicer profile up to 250 millimeters per second. I've been printing at 120. And this dragon, which really is quite nice, printed in 6 hours and 54 minutes. Now, I also turned on a Cura feature. This feature is also available in Prusa, called Lightning Infill, where it minimizes the infill. That was probably a mistake for this dragon because you have to put a lot of force on the wings to get them in the base. They print separately, and the lightning infill was not strong enough for that purpose. In addition, I pulled a lot of it off. There's a really lot of stringing on this model. So I wasn't enough stringing that it almost impacted the quality. So I thought, okay, let me slow everything down and see if I can eliminate the stringing. So I printed this at 120 millimeters per second. I turned off lightning infill. It took 9 hours to print, about a third longer. And it's a much stronger print, a better print overall, but there was still a lot of stringing. And just as there was stringing on this model, which you can see here, but there was no stringing between the ears of the rabbit or on the benchy. So they must have something set differently. So I began doing some experimentation. And I'll show you the result of that experiment. I ended up setting these settings for the highest quality prints. 120 millimeters per second. I dropped the temperature of my PLA print down to 198. I might go 1 degree lower. I set the print bed up to 65. They had it at 50 in the default. And the reason is I saw a little tiny bit of warping in some of the samples that I don't have here on the screen that I printed. So I believe that's because the fans are so good that it might be cool off the print a little too fast and it might warp a little. So I made the print bed a little bit warmer. I set either cubic or lightning infill at 15%. And I actually turned on horizontal hole expansion just a little bit. I'll show you why later. I might have to adjust that a little more. I think on this particular printer, I haven't measured it precisely yet. It's all over extruding just a little bit. Now, when I did that, I then printed a calibration cat, and this calibration cat came out pretty good. I have a caliper here. Let's take and, let's zero it out. And let's put this in, let's see if I can direct this so you can see it. So let's get it in the right spot here. And it's supposed to be 20 millimeters. It's 20.12. It's pretty good. Let's go here. 20.02. And there is no stringing at all on this print. So then I printed the Kickstarter torture test for 3D printers. And this is a beautiful print. I'll show you a couple things that are important. You'll notice there's a lot of stringing at the very top. Well, many 3D printers won't print the top of this tower at all because the spears, whatever the correct pronunciation there, somebody write in the comments how to pronounce that. They're very, very, very thin. But down here at the bottom, where they're about 1 to 2 millimeter stalks, there is no stringing at all. The overhangs here, whoops, well, the pins are supposed to come out on here, and the first 3 pins did come out. The last 2 are not coming out. So once again, I might drop the temperature 1 more degree and make the retraction just a bit higher, or hole expansion a bit bigger to get those last couple pins out. But one of the features on this print that often causes a problem are these overhangs here. And they're really, really clean on this print. And this overhang on the bottom is real clean. Now, why is it so clean? Well, I think it's those excellent fans. I think there's good extrusion control, good temperature control, and excellent fans. So what is my conclusion about this 3D printer? I stand by my earlier statement that this may be one of the best 3D printers Creality has ever made. It's very rigid. It goes to 300 degrees. It has excellent, excellent fans. It has auto bed leveling included. It includes power fail recovery, but I wouldn't use it because I think it's more trouble than it's worth. They've also done some interesting things. The stepper motor on the Z-axis is physically bigger and a different model number than the other stepper motors and on the other Creality printers I have. So they've done things to ensure that at higher speed, it will operate properly. So who should buy this? Well, if speed is important to you, with high temperature and high quality, it's worth the almost $600. If you don't need the speed, you can get the high temperature by buying an Ender 3 S1 Pro. It's about $100 less. You won't be able to enclose it though, because this has this square body that is easily enclosed for a little more than $100 with a kit from Creality. If you just want blinding speed and you can have a little less quality, quality's not necessary for you, there's some Delta printers out there. I'm going to be reviewing a new one that do a good job, and we'll see if they've upped their game in terms of quality. In general, I found the Delta printers, and I have an Flsun Super Racer that I love. I use it for a lot of prototype prints because it's so fast. It's even faster in this printer, but the quality is not as good as I can get off of this particular printer. So there's a lot of choices today for people. You can buy a really good 3D printer from about $250 on up. If you're looking at the top end of the market, I think this is an outstanding, outstanding choice that's fast, high speed, enclosable, has all the features we need. Well, folks, thanks for watching. I hope you enjoyed this. I hope you learned something today. If you did, give me a thumbs up, subscribe to the channel. Please share the channel with everyone you know, and go to models.makewithtech.com to find 3D models that you want to experiment with and print, and go to forum.makewithtech.com to discuss the things you've learned. Have a great day, and let's continue to learn things together.